channel Be Always Learner. Today we are going to study the basic operations on signals. The operation on signals is divided into majorly three parts. The one is related to time. These are the three operations which are going to perform with respect to time, and this kind of operation is related to amplitude, and these two operations are between the signal. Say suppose there are two signals or more than two signals which are operated using these kind of operations. When we are talking about time related operations, there is a time shifting. Time shifting is divided into two parts. One is a time delay, another is time advance. In time delay, we are subtracting some constant from the time index and adding certain constant on the time is called advancement. Another operation related to time is time scaling. We can compress by multiplying a constant, and by dividing we can expand the signal. Another important operation is time reversal. We have to change the sign or multiply it with the negative 1 with time. So this is nothing but we can call a time scaling function. It is a type of time scaling function, as we can multiply -1 with the time. The another kind of operation is amplitude related operation, that is amplitude scaling. In amplitude scaling, we are having two kind of multiplication. One is higher than 1 and another is less than 1. If it is higher than 1, then it is amplification. If it is less than 1, it is called to be as attenuation. And another kind of operation, when the more than two signals are available, then we can multiply these two signals or more than two signals, and addition of two signals is another kind of operation when we are going to extract certain information by adding two kind of signals. In this particular session, we are going to understand only time shifting. In time shifting, for your understanding, we are able to manage a signal x, which is a rectangular signal, and starting from the -t and t, and on the y-axis we are representing x. To represent the advance, what we can do, we can add a constant t time into the time index, and after adding we are getting this signal. Now we have to map this particular -t on this particular output. For that, what we have to do, if there is a negative sign, just this is a thumb rule, if there is a negative sign or positive sign, in the advancement there is a positive sign, then we have to subtract -t from this. So to get this point where it lies, then what we have to do, we have to subtract the quantity which is added to the signal t. So it is going to be -2t. So it is -2t. Another one, this is 0. As you know, this is 0. Where this point is going to lie? The simple formula that we have to subtract -t from this. This is going to be -t, right? So here the point is -t, and we have to track this point also. So this is t minus t, that is going to be 0. So this point is going to map here. So it is quite simple. In the same fashion we can calculate it. There is a negative sign, and to track all the points here, we have to add -t, because there is a subtraction, then we have to add it. This is called to be as a delay. Now there is a one point -t. To get this, what we have to do, there is -t plus t. This is going to be 0. So it is going to be mapped on this side, right? And this 0 is going to be uh, just we have to make it like this, 0 and plus t. So it is going to be on this one, this is t, and this point is t and plus t, this will be 2t. So 2t will be lying here. So in that way we can map the individual point on the another output. Another concept here is time shifting in case of discrete signal. We have to understand the time shifting into discrete domain also. So for that we have to consider here one example, that xn is represented by the three non-zero sequence components 2, 3 and 3. Now we have to calculate the advanced version of 2 of the sequence by 2. Now it is a representation that is xn plus 2. Here is a plus sign. So as in the previous case, if there is a plus sign, then what you have to do, we have to subtract 2 from each point on the time domain. Now this is 0, so 0 minus 2, it is going to be minus 2. So the 2 data point here is represented at minus 2 here. Another is minus 1, so we have to subtract minus 2 out of this also. So we landed with the minus 1. So this 3 point is represented here. Another, this 2 point we have to subtract from this 2 also. Then we have 0, so it means this 3 is represented at 0, and so on and so forth. This is advance. If I am going to subtract minus 2, that is a delay, and because this is a negative sign as in the previous practice, we have to add 2 in these 3 data points. So for that we have to do again the same exercise, that this 0 plus 2, this is going to give us the location of this 2 data point. So it is 2, so we have to make it 2, and another is 1, we have to add 2, so this is 3. So this 3 is located at 3 after delaying it by 2, so this is 3, and we have to add 2, so this is going to be 4, so this 3 is located at 4, and so on and so forth we can calculate. From this example it is concluded that if I am going to advance the sequence by 2 or by k number, then the sequence or the signal is going to shift on the left side, and if I am going to delay the sequence by 2 or by k, it is going to shift on the right hand side. So this is right hand side shifting, or we can say delay, RHS, and on left side we can say LHS. So directly we can understand the another example. We are going to consider that the continuous time domain signal is represented here, xt is equal to ut t minus 1. So u is unit step input, so unit step is represented by ut is equal to 1 when t is greater than 0, and it is 0 when t is less than 0. So graphically it is represented here that ut is having value 1 after 0, and before 0 value is 0. So we have to shift it by 1 as the question says. So for that, if it is a negative sign, because it is a delay, it is a negative sign, so we have to add 1. So in this 0 we have to add 1, so it is landed with the 1, so it means this is 1. So we start the signal on 1, and after 1 the value is going to be 1, and before 1 value is 0. Another example of the advancement, that we have to add 1. So to give the advancement by 1, if I this is a question given, then ut is again represented in the same way, then it is addition. So if it is 0, then we have to subtract from this to get the map of this. So this is -1, so this is -1, it is located at -1. So after -1, the value of the signal is going to be 1, and otherwise before this the value is 0. The same type of example is considered for the discrete time signals, that the question is given un -2. We have to obtain it. So what is u? U is unit step input. So un is defined like it is 1 when n is greater than 0, and it is 0 when n is less than 0. So it is mapped here. After 0, the value is going to be 1. So this is the representation of un, and we have to calculate un -2. It is minus, so it means we have to add +2 in all the points to get the mapped output. +2, +2, and +2, right? So we can correspondingly get the points. So this is 0 plus 2, it is going to be 2, so we started with the 2. It is 1 plus 2, this is 1 plus 2, so this point is located at 3. It is 2 plus 2, so point is located at 4. It is 3 plus 2, the point is located at 5. It is 4 plus 6, the point is located at 6. So for your convenience, we can represent it here also. So this is calculation of un -2, and now it is un plus 4. It is plus sign, it is representing advance. And if it is advanced, un is defined again by the same set of mathematical representation, and we can graphical represent it like this. It is n plus 2, it means at every point we have to subtract 4. So minus 4, minus 4, minus 4, minus 4, right? So 0 minus 4 is minus 4, 1 minus 4 is minus 3, this is minus 2, and this is minus 1, and so on and so forth. So this 0 point is located at minus 4, so this is this one, and if it is minus 3, this 1 point is located at minus 3, and this minus 2 point is located at here, and minus 1 point is located here. Rest of the points we can represent, because all the points on the right side is going to be 1. So hope you like and subscribe our channel